This video is sponsored by Squarespace.
In race car design, less is usually more, almost always actually, and not just less as in fewer parts. Less unnecessary space, less tangled wires, fewer fasteners, and less complexity in packaging will almost always give you a better overall car. One of the easiest ways to simplify and optimize packaging is with CAD, but anybody who's ever worked with CAD will tell you that just because it works in the computer does not mean it works in real life. A lot of time is spent fixing the discrepancies between CAD and real life, and the differences will often reality check your unrealistically optimistic deadlines into the next time zone. The idea of this upgrade was to swap in a new engine and turbocharger while changing as little else as possible. Basically, we changed the stuff in this part of the car and everything else stays the same. But of course, that is not happening. Already I've talked about modifying the front coolant tank to fit the water pump and running new coolant lines through the frame, but we have a lot of other non-engine bay things to do. The first thing is safety related. I sit on this aluminum panel that is reinforced with a lot of warning stickers. That sits above these frame tubes that cross under me. It was suggested by one of the safety crew that I reinforce this area with more tubes. Apparently, in the high G-forces of a crash, it's not unheard of for part of an occupant to come out through the floor pan, and this sounds like a really bad time. Having my ass cheeks sanded off with sandpaper literally made of 200-mile-per-hour salt sounds like pretty much the worst possible day. Plus, my ass is one of my best features. Should probably put it in more thumbnails, get some more clicks. So I decided to reinforce the floor by crisscrossing the tubes. The reason these tubes don't meet in the middle is because I messed up the measurements and then just welded them in anyway. Or maybe I did it on purpose to better box out the floor openings. Maybe I'm secretly really clever. Either way, reality no longer jives with CAD, and that could be a problem for future Matt, but it's not a problem for me, so let's move on. Another thing that needed to be done was rust cleanup. I didn't get any video of this because I tend to not record things I don't like doing, so just use your imagination. Pretend I drove this car on a race course literally made entirely of salt. That's how much rust there was. The firewall had a lot of holes for pass-throughs and bolts to mount things, and I'm not using most of them again, so I ordered the smallest diameter pucks that SendCutSend could make, drilled out all the holes to that size, and then welded them all in. Earlier, I cut out a section of the frame and made it removable so I could get a new engine in and out. Well, now this side of the frame is a little flimsy for my liking. It will be fine when that frame tube is installed, but to add some rigidity when it's not, I welded up another parallel frame tube that will run just below the clutch on the engine. There was one other big frame modification that I needed to make. The new engine has these lower mounts right here. There needs to be some kind of bar going across with two tabs welded on, but a while back I added these locating features into the frame. There are 4 of these aluminum cones on the trailer that locate into these holes, keeping the car safely on the trailer when towing. Well, the rear 2 holes are right where that bar wants to be, so I decided to replace those mounts with a bar that does both things. It has the motor mounts on top, and on the bottom there are 2 holes drilled for locating on the cones. I flipped the frame upside down to get easy access to chop off the old tabs, and the frame started leaking oil. I'm usually pretty good at not having oil leaks in my vehicles, but I've definitely never had a frame oil leak. My guess is that I got oil inside when I lost my oil coolant hose during a run at Speed Week. The oil that was in there was just captured until I flipped it over. Or maybe I put the oil in there on purpose so the inside of my frame wouldn't rust. Maybe I'm secretly really clever. The tabs were removed the same way all difficult tasks get accomplished, with noise and profanity. I made this bar out of stainless since it will get a lot of abrasion with the locators and since it will get filled with salt and dust. With the new bar welded in, I carefully marked the hole locations and started drilling. Unfortunately, drilling those holes out in stainless with a step drill bit completely toasted my angle drill. Furtherly, unfortunately, the reason I was using my angle drill is that my main drill had shit the bed earlier in the week. So I was without a drill. I took a break, spent a few $100s, and then finished it up a couple of days later. In my last video about the car, I made an ice water tank by welding up some 2-dimensional laser cut parts into a tank. Unfortunately, 2 dimensions is not very good for insulation, and the ice water tank will be in a very hot engine bay, which will make it not ice water very quickly. I didn't talk about this last time because I hadn't finished it yet, but I do have a solution for that. I wrapped the whole tank in a 3D printed plastic blanket. Before I made the tank, I shrunk the design by 1/2 inch in every dimension. Then I designed a 3D printed case that it slips into. If you watched my video on insulating my van, you might remember that I used 3D printed parts for my floor, partly to help level out the floor and partly because it makes a good insulator. Aluminum is a terrible insulator. In fact, it's an excellent conductor, which is the opposite of what I want here. Plastic is a pretty good insulator, especially when you 3D print it, since you can infill a bunch of small pockets of air. That's really all most insulation does anyway. It traps small pockets of air. I did have to split it top and bottom to fit it in the printer, but I had to do that anyway to get the tank inside. The tank is kind of big, but I do have the large printer, the H2D, and it does just fit in there. By the way, Bamboo is supporting this build. If you want to support the build and also make your own multi-dimensional solutions, click the link below and check out the H2D. The top and bottom halves are held together with screws and heat inserts. Heat inserts are awesome. You heat them up with a soldering iron and then press them into holes in 3D printed plastic. The heat inserts go in the top, and then the bottom has flathead screws that are screwed in to clamp it together. The other big advantage of printing a thermal jacket for this tank is that I can add a bunch of extra features for free, or basically free. There's a mount coming off the front that holds the water injection pump, then I added 2 mounts to constrain the coolant hoses. There are heat certs on the side that the vehicle control unit mounts to. There are heat certs on the bottom that allow it to be fixed to the floor. I even added some extra pockets in case I want to add threads in the future to add other things. I printed this out of ASA. This is a great material for a few reasons. It's decently strong, it prints well, it will hold up over time, and it has a pretty low thermal conductivity. I undersized the aluminum tank from the plastic walls by about 2 mm with a plan of adding in some foam if I needed it. But of course, a welded structure is not going to be exactly dimensionally accurate. Fortunately, it just barely fits without any padding, so I just jammed it in there and called it good. One of my least favorite things about the old setup was the fuel system. I was using a fuel tank from a junior dragster, which was fine, but the pump situation was awful. I had a pre-filter and then a pump and then a filter with a built-in regulator, and it was all connected with janky fittings and poorly attached to the car. This should have been replaced long ago, but it wasn't, so now seems like a good time. I talked about this last time, but the fuel tank up front here is between the intercooler ice water tank and the fire bottles. To simplify this mess of filters and pump, I decided to put most of it inside the fuel tank. I want this tank to be as robust as possible, so everything is coming in from one hole in the top. I bought a fuel pump hanger, but there were some problems with it. The big one is that my tank is very tall, so the hanger is not long enough, and even if it was, it would be way too flimsy. I also decided, after talking with some knowledgeable people, that I should go with 2 fuel pumps. One could probably handle the power I need, but it's close to the limit, and I like the redundancy anyway. I'm using these Walbro fuel pumps. There are a few different flavors of these in terms of flow rate and pressure, but they all are the same form factor, and they've been around for a while, making lots of power. Adding 2 fuel pumps on the bottom of an already flimsy pump hanger did not make things better. And it wouldn't work anyway because the hole would only be big enough for 1 pump. So I did what I always do when things seem not ideal. I spent too much time and money to just redo it myself. This is my dual fuel pump hanger, and it is a pretty amazing feat of engineering design if I do say so myself. This is a combination of 3D printed stainless steel along with some stainless tube and some welded AN fittings. At the bottom we have this clamp situation that holds 2 pumps. The pumps are held on with stainless steel hose clamps. The fuel from the 2 pumps comes together in this middle part to a port where I welded an AN fitting. I added a plug here that's welded on. This is just so the powder from metal 3D printing can easily be cleaned out. The stainless tube going up from the lower clamp and up to the top plate does 2 things. One is that it rigidly holds the whole assembly, and 2, it is the return line. I have a fuel pressure regulator on the fuel rail, and the return line comes in the top and down this tube so the return fuel doesn't splash into the top, creating bubbles. The top plate has passages for the outlet and the return, both with welded fittings on them. I added pass-throughs for the ground wire, 2 separate power wires so I can control the pump separately, and an auxiliary wire that is unused now but may later be used for a fuel level sensor. The pumps have little pre-filters on them, and I have another filter after the junction. With the whole thing assembled, I very carefully inserted it into my fuel tank and pretty much immediately found out it wouldn't work. The holes for the bolts were just barely too small, so I very carefully removed it from the tank and drilled those holes out. Then I very carefully installed it back in the tank and inserted all the bolts, and then I realized that I forgot to put sealing washers on the bolts. So I had to carefully remove it again. But I didn't get a video of me carefully removing it this time, so I hired Nick Cage and Sean Connery to reenact it for you guys. I bought new fire extinguishing bottles for the car. The rules require at least 11 pounds of fire extinguishing agent. I have 20 pounds because I don't want to be on fire. That sounds like a bad time. I was using a different system before, but I didn't like it because the bottles were bigger, the mechanism was not robust, and they didn't come with gauges showing pressure. So I decided to switch to these new bottles. I made a mounting solution for these bottles where the bottom was secured in a 3D printed receiver and the top was held in with clamps attached to a piece of angle aluminum. I changed this for a couple of reasons. One is that I just don't like the 3D printed receivers at the bottom. Even printed out of solid nylon, I don't trust them to hold up to a really significant impact. If they come loose in a crash and then I catch on fire, they do me no good, and I really don't want to be on fire. Especially not at the same time my ass cheeks are being sanded off by 200-mile-per-hour salts. I'm starting to think this might be a little dangerous. The new bottles are shorter, so the aluminum angle has to be moved to the bottom of this bar, and there are several things in the way that turn it into a flimsy bit of Swiss cheese. So I changed the bottom to be supported by a welded stainless bracket that holds 2 more clamps and is bolted to the frame of the car through the floor. On the top mount, that angled bracket stayed an angled bracket, kind of, but I made it out of 3D printed stainless steel, adding some features to make it stronger and stiffer. And now I'm pretty happy with the structural integrity of the fire bottle mounting. This was the first thing I installed in the engine bay, and that's when I found out that not all of the frame was in the CAD model. Like this feature here that connects the front and rear frame together. So I had to bandsaw out chunks of the part that I just had laser cut before I welded them together. After that was done, I found out that this bar here was also not in the CAD model, so I had to cut that out to get the fire bottle to fit in. After that, I found that this part of the frame here was interfering with the bottle, so I had to cut that back as well. I definitely should 3D scan the whole frame engine bay and make sure everything else is in CAD. I also made engine mounts that don't work because everything is off by just a little bit. I considered making these out of stainless in case I needed to modify them, but I decided to make them out of mild steel and have them zinc coated for salt resistance. Well, after welding them all up, the rear mostly works, but it's clearly at an angle. The right side is a little bit off and the left is way off. So I'll be rescanning this all, redesigning all the mounts and making them out of stainless. I am leaning pretty hard on CAD to make this happen, and there are a lot of things that are either not in CAD or just wrong. This is going to be a problem for future Matt, and apparently we don't like that guy very much. It wasn't just stuff absent from CAD that was interfering, some of it was just good old me not paying attention. The strap that holds down the heat exchangers occupies the same space as one of the angles that constrains the fuel tank. This is, unfortunately, against the law, so I had to remove the angle and chop it to fit. With the fuel tank installed, there's supposed to be a gap of about 3 millimeters between the fire bottle and the fuel tank, but they are actually touching. We traced this back to the straps that hold the fire bottles having a different radius than the bottle, and since it's too late to fix it in CAD, we fixed it in the real world. This almost doesn't work. The cap for the ice water tank threads out to where it can just barely be removed. I packaged that a little too close. Or maybe I did it on purpose to maximize space. Maybe I'm secretly really clever. An hour into installing parts and pretty much nothing fits without modification, but I do have the front half of the engine bay mostly all installed, so we are getting somewhere. The fuel tank and ice water tank are held in place with this bar on the top. It bridges the 2 bars that triangulate out the roll hoop. This is another place where CAD doesn't meet the real world because there is not supposed to be a gap here. We cut new metal pieces to fit, and I will figure out what the discrepancy is later. The ice water tank has 2 threaded heat inserts that will have bolts threaded into them through the bar. I printed a jig to get the holes drilled in the right place, and then sent off this bar assembly to be zinc coated so that it will hopefully not turn into a solid piece of rust. The fuel tank doesn't have any threaded fasteners. It is constrained with those 2 angle brackets on the bottom sides, the firewall in the front, the heat exchanger strap in the rear, and on the top with this bar across. The tank has ears coming off the top to catch the front and rear of the bar, and the bar has ears coming down to further constrain the tank side to side. The idea here is that in a wreck, the tank will stay in place, but there won't be any rigid welded mounts that can rip out and leave a hole in the tank. This is part of the same reason that passenger cars use straps to hold their tanks in place. I think I have designs done for all of the rest of the major parts, at least basic CAD designs. I mounted the turbocharger in a place that interferes with the oil filter, leaving that as a problem for future Matt. Well, future Matt is now present Matt, and there is not a great solution for this. I assumed I could find a shorter filter, but Suzuki uses a unique thread that literally nobody else uses for oil filters. I found a website selling an adapter for a more common thread, but the website looks like it was designed 20 years ago. I ordered one partly expecting that it was a defunct website and my money would disappear, but it did arrive a few days later. Even with this adapter, there's only one filter I can find that will fit it, and it's only about 3.5 millimeters away from the turbo, which seems really tight. You can buy a 90-degree filter adapter, but it looks like that will just cause a collision with a different part of the turbo. Still, I ordered one and I'm going to scan it when it arrives and see what works. Maybe I can just angle it down a little bit. Alternatively, I'll just redesign part of it and have it machined so that it fits. That sounds expensive and complicated, but that is a problem for future Matt. And f*** that guy. Routing all of the exhaust and air to and from the turbocharger is really challenging. I'm trying to keep airflow reasonably smooth, but there's just so much in the way and everything's fighting for the same space. A lot of this is 3D printed, some of it metal, some of it plastic. I sent off some of the metal pieces and I'm a little worried that things are going to show up warped because of the complex geometry, but we will see. This tube here might be the last thing I have made. I'm going to have to assemble everything and then 3D scan it in the car to see where everything ends up, because there's no way this is all going to be exactly how it is in CAD. But I am getting ahead of myself. The next big step is to build the engine. The rest of the parts will be arriving soon, a little bit late, and then I get to assemble it all and do a bunch of other things. The schedule is tight, which comes with stress, but it also comes with some excitement and motivation. I do kind of like things to be a little bit behind schedule. I never really planned to make things that way, but maybe there is a subconscious part of me that does it on purpose. Maybe I'm secretly really clever, or maybe I'm just kind of bad at things and also a little bit lucky. And maybe that's good enough. A big part of being a good engineer or fabricator is having the right tools, and I sometimes do. Sometimes I just wing it with whatever I have lying around, and I regret it later. Making a great website is also best done with the right tool. Thankfully, today's sponsor, Squarespace, has just the right tools to make you look like a great website designer. Squarespace has several professionally designed website templates with options for every use and category. You just pick the one that best suits your needs and customize it. If you want your website to be totally unique, you can use Design Intelligence to craft your digital identity. Design Intelligence combines 2 decades of industry-leading experience with cutting-edge AI technology to help you look like a professional website designer. You can set up an online store to sell your unique and interesting things, customizing product listings with images, videos, add-ons, and related products. Head to squarespace.com for a free trial, and when you're ready to launch, go to squarespace.com/superfastmatt to save 10% off your first purchase of a website or domain.